Well, today we're going to be talking about goodness of fit and how to use the calculator to be able to solve these. So if you look, there's a lot of words on these pages and stuff like that. So I thought what I'd do is kind of help you walk through example 1 and 2 and what to try to type into the calculator and show you how to do that on the calculator as well. So the main things that we need to recognize for goodness of fit is there's always going to be two columns of data. So the observed, so that's actually what's been listed. So like if we look at example 1, the observed values are the actual number of false alarms that they had. So in this case 32, 15, 37, 38, 45, so on the whole way down. And so these are going to be our L1 values. So these are going to go in L1. And then the expected is where this is actually coming from over here. So in this case, if there's 100% of possible fire alarms, if we divide that by the number of months, that gives us 12. So that tells us that's at approximately 8.33%. And so if we add these up, there was 427 false fire alarms that were calculated. So if we do the 427 times the 0.0833, and we're going to enter that into L2 for each and every one of these different values. So, and then after we do that, we've got to do a little calculation to come up with the critical value, and then we'll use the calculator to actually solve this out. So let's go ahead and put these data values in the calculator. So let's see, I should have written them down somewhere else. I'm going to have to keep bouncing back and forth. So let me pull up the calculator real quick. So I'm using Graph Calc, and but this emulates the TI, which is the nice thing. So what we want to do is we first have to put this stuff into our list. So if we hit Stat and then Edit, we're going to put the observed in L1. And so I've already forgotten all the data here, so let me go back. So we've got 32, 15, 37. So 32, 15, 37, 38, 45, 48. 38, 45, 48. 46, 42, 34. And then finally, 36, 28, 26. Oops, I made a mistake. So this should be 26. All right. So then in our expected column, that's where we're going to do the 427 times the 0.833. And we just want to keep typing that the whole way down until the columns of the list actually match up. So in this case, we're going to do 427 times, oops, times 0.08333, and just keep doing this for each one of them. Seven times 0.08333, 27 times 0.08333. Almost done. Should be last one. So again, at this point, you'd want to go back and make sure everything's typed in correctly to make sure we didn't make any kind of mistakes or anything like that. Because if we've obviously typed in the data wrong, it doesn't matter whether we do the rest of the stuff right or not. So go back, check your work. So I'm going to assume I've typed everything in correctly, hopefully. So now what we want to do is hit second mode to get out of that method. And so what we've got to do now is come up with our critical value. So what we're going to do is we want to type in parentheses and then L1. So notice L1 is this on the number 1 button. So if we hit second 1, second 1, that gives us L1 minus L2, so that's second 2, parentheses, caret squared, and then divided by L2. And then what we want to do is we want to store this in list 3. So if we hit the STO button over here on the left, it looks like a little arrow, and then second L3. So in this case, this actually puts all this into L3 for us. So if we actually go back to stat edit, now we can see that that calculation is in L3, which is perfect. So hit second quit to get out of this. So now we want to figure out what the critical value is. So this is where we want to sum L3 together. So to do that, we want to go to second list, then math, and then number 5 is sum, and then just do second 3 to get L3, and then hit enter. Oops, so that's not a good way to present it, but let's see, let me change this mode to decimal. Instead of fraction. There we go. So it looks like our critical value is going to be 27.7926, blah, 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 blah. So now from there, our alpha level, I think was 0.01 on this one. Let me check. Yeah, so our alpha level is at 0.01. So now we're ready to finally do our chi-squared goodness of fit test on it and check our p-value against our alpha value. So if we go back to the calculator, hit stat, hit test, and then we're looking at, in this case, D, the chi-squared goodness of fit test. So our degrees of freedom were 11 because there were 12 data values total, so that means we want to have 11 degrees of freedom. And so on mine, I'm just going to hit test. Whoops, I don't want to do that. Just hit done. Oops, hold on. Oh, there we go. And so now I can see down at the bottom, I've got my p-value of 0.003. 4, which is less than 0.01, so that means we want to reject H naught. So there's significant evidence to show that these things wouldn't be random, is the idea. And so if we go back to the notability, that's the exact same thing that Val had gotten also in that case. And if you see, there was our critical region, and if you see on Graphing Calc, they actually draw it, so our critical region matches and everything, which is nice. So it looks like we did a good job on that one. So let's do the M&M one real quick for my iPad dies apparently. So this one, there's less data values. So again, what's given is our frequency. So these are the observed values. So again, these are the ones that are going to go in L1. And then the expected values are actually coming from these percentages. So in this case, so this is brown, this would be yellow, this would be red, this would be blue, this would be orange, and this would be green. So we're going to get different values for each one of these. So if I were to kind of write the expected over here, then for brown, we're going to take the 0.13 and multiply it by the total, which is the 400. So that's going to give me my L2 column. So this is going to be L1, this is going to be L2. So yellow is 14%, so we're going to do 0.14 times 400. Red is 13%, so 0.13 times 400. Blue is 24, so 0.24 times 400. Orange is 20, so 0.20 times 400. And then finally green is 16, so 0.16 times 400. So again, let's switch over to the calculator, get it ready so we can start putting the data in. So let me go to Stat, Edit. So the first thing I have to do is clear out all this old data. Alright, and so in list 1, so I want to list the table values, so 61, 64, 54. So 61, 64, 54. And then 61, 96, 64. And then again in L2, so in this case, I'm not just going to copy the same thing over and over and over. I've got to copy what's there, so whatever percentage times 400. So in this case, we had 0.13, 0.14, 0.13, all times 400. So we have 0.13 times 400, 0.14 times 400, 0.13 times 400. And then 0.24, 0.20, 0.16. 0.24 times 400. Whoops. 0.20 times 400. 0.16 times 400. So again, now that everything's in there and calculated, we want to quit out of here, so second mode. And then do that same thing again. So second L1 minus L2 squared, all divided by L2, store in L3. And then again, we want to sum this. So go to, whoops, not stat. Go to list. Oops, not alpha. Jeez. Math, sum, so second L3. So this is going to be our test statistic, the 8.737, so that looks good. So now to test this out, so the main thing to remember is, so there were 6 data values, so that means our degrees of freedom is going to be 6 minus 1, which is 5. So if we go back to Graph and Calc, Stat, Test, goodness of fit, so our degrees of freedom is 5. Whoops, and then I gotta go back again apparently. Goodness of fit, and again, so we see our picture, there's our 18.737, our critical value. Our p-value is 0.002, which I think in this case the alpha was 0.05, so that's significantly less. So again, we would reject the null hypothesis again, and it tells us that these fire alarms really don't appear to be random. So see if this helps a little bit, and if you still have more questions, let me know.